Okay guys, good morning guys. Today inshallah we're gonna start a new chapter. So we already done with chapter 5, the 4 sections, so we pass to chapter 6 now. We start by section 1, gravity and motion. So actually in gravity and motion we're gonna go through many goals or something or many ideas that we should know. First thing, we should know what the effect of gravity and the air resistance on falling objects. That means how gravity and the air resistance could affect the movement of object while it fall down. Then explain why objects in orbit are in free fall and appear to be weightlessness or weightless. Why they just without weight, although they have mass, and of course there is weight. Describe how projectile motion is affected by gravity. So that's what or that's the main ideas which we're going to go through within this section. So let's start by the first point here, or that's how the effect of gravity on the object, on the falling object, and how the air resistance could affect this. So here, regarding to this point, we're going to say gravity and falling objects. So the question is, or we have a very important question here, guys. I want everyone to pay attention. Imagine that, for example, if we get here like that is a football, okay, for example, and that's here like a scrambled paper, okay, so that is a paper, while this is a football, and we start to make both of them fall down from the same height, okay, so for example they are at the same height, just 10 meters. So which one will reach the ground first? So we ask which one will reach the ground first. So actually most students they are gonna think that the football will reach the ground first before the paper, and that's the most common thinking for most students, because they thought football has a higher mass than paper, has more weight, so it will be attracted more toward the ground, so it will reach first. Actually that is false, it's not like that, because both of them they will reach the ground at the same time. How both of them will reach the ground? Because you already said the answer in your explanation, but you don't care about it. What is that? We said both are under the same gravity. Both are moving under the same force. So whatever the object is, it will just keep attracted by the same force, attracted by the same gravity. So both of them will move with the same acceleration, which is the gravity acceleration. So here, which equals 9.8 meter per second square. So both will move with the same acceleration. So it means both are gonna reach the Earth at the same time as they are falling from the same elevation. So to clarify the idea more and more, look with me here, guys. Okay. So So like this, you said gravity and the acceleration objects fall to the ground at the same rate, because the acceleration due to gravity is the same for all objects, which means all objects are already attracted by the same gravitational force. So here there is no difference. Both they are working under the same force, so they will accelerate with the same rate. So here like this, let's see. Here, for example, guys, we are gonna find this pole is got falling down. So in the first, the velocity, or that's mean here, the speed of the pole equals 0 meter per second, because it's still not moving. After a while, after just 1 second, it already accelerates by 9.8 meters. That is the acceleration due to the gravity, or that means how the ball will speed up because of the gravitational force. So as it is, the gravitational force is constant, so of course the acceleration will be constant. So that means each second it will accelerate by 9.8 meter per second. So here like this, we're gonna find after 1 second its speed will be 9 meter per second. After 2 seconds it will be 19.6, which it means it accelerates the same rate and keep accelerating like this until it reaches the Earth. So whatever the object is here, we don't care about the mass of the ball, whatever the mass is, this ball big or small, whatever the material it's made up of, we don't care about this. We just care about the acceleration that's happening to the object due to the gravitational force, and as the gravitational force is constant, so this acceleration will be constant too. So here like this, guys, simply we figure out that gravity and falling object, we're gonna find velocity of falling objects. We could find the velocity of the falling object by using the next formula. So we say, or this law, delta v, that means the change in velocity, equal g, which means the acceleration due to the gravity or gravitational force acceleration, multiply the times or the different intervals period of time. So here we're gonna find, in case of the beginning, the ones that mean the ball before it falls down, of course here in this case we're gonna find that the acceleration equals 0. It doesn't move yet. Okay, once you start to move it after 1 second, so the time will be 1 and the acceleration will be 9.8, so that means the speed will be 9.8 meter per second, and so on. To be more clear, okay, let's look for this example here. He asks you calculate the velocity of the falling object. A stone at rest is dropped from a cliff and the stone hits the ground after time of 3 seconds. What is the stone's velocity when it hits the ground? So here, that's a very important question. So we're gonna find how we answer a question like that. So the first, we're gonna use the rule that delta v equal g multiply t. So then we said that delta v, that means the velocity, we don't know it, that's which we need, and the gravitational force is fixed 9.8 meter per second square, multiply the time, so 3 seconds. So overall we are gonna find that the final speed that the stone will reach the ground, it will be 29.4 meter per second. Okay, so here of course sometimes in other problems it may give you the amount of the speed and they give you the gravity acceleration and ask you to find the time. So always we have two variables that we keep, okay, looking for speed or the time. So let's try to answer the following questions here, guys, and try to find the answer together. So here, for example, just a minute. Okay, here he said that now let's try. He said that a penny at rest is dropped from the top of a tall stairwell. Okay, what is the penny's velocity after it has fallen for 2 seconds? So he got that he started at first and he asked you to find its speed after he has already fallen for 2 seconds. So the rule is that delta v equal g multiply t. So here in this case, we're gonna say the delta v will equal, the acceleration is 9.8 multiplied time is 2. So delta v will equal, okay, in this case, it will 19.6 meter per second. Yes, it's true. Here, that's how we could answer the first one, okay? So then, so here then the second question, we said that the same penny hits the ground in 4.5 seconds. What is the penny velocity at when it hits the ground? Okay, so the same steps we're gonna do, but instead of using time 2, we're gonna change the time to be 4.5. So 9.8 multiply 4.5. Okay, so of course you use your calculator to get the amount, so it will be whatever meter in second, and like this you answer number 2. So here in question 3, a marble at rest is dropped from a tall building. The marble hits the ground with a velocity equal 98 meter per second. How long was the marble in the air? So here he needs to find how much of the time needed until it hit the ground. So here let's see, we said that delta V equal G multiply T. So he got the velocity 98 equals the gravity 9.8 multiplied, so the time. So we can say time equal 98 divided by 9.8, so it's equal 10. So 10 seconds until it reaches the ground. So here like this, that's how we could answer the different question regarding to this. So I think it's simply or easy here to find. So what we figured out from this, we figured that all objects, whatever the object is, they keep moving with the same acceleration when they are in free falling or once they fall to the ground. And here no effect for the mass of the object or its size. So then here like this, guys, we know this. Then we pass to the air resistance and falling object. Does air resistance play a role in falling objects? Of course. Here we see that resistance, that the force that opposes the motion. It's kind of friction, but with the air. So it's the force that opposes the motion of objects when they are moving on the air. So here like this, of course, the amount of air resistance acting on object depends on the size, the shape, and the speed of the object. That means as the size increases, so of course here it will face a lot of air resistance. Shape also, that means the more streamlined shape, the less air resistance that object face, and the speed of object speed up, the air resistance start to increase. So here like this, all these factors could affect the movement of an object in the air. So here we're gonna find, for example, the ball. Sorry guys. So we can find the ball is already fall down here. So it works under the effect of gravity, of course. So that's one force applied to already the gravity attract the apple toward uh, toward the ground. At the same time, the air resistance is working in the opposite direction. But here, as we know, as there are two opposite forces in two opposite directions, so we are gonna find that the net energy, we are gonna minus them, and we are gonna find that here the gravitational force is more than the air resistance. So finally, the apple will fall down, but actually it will not fall down with the same acceleration in absence of the air resistance. It will be less than usual because we have an air resistance that slow down the falling of this apple. So here, guys, that's the part which we're gonna stop at. Next time, inshallah, we're going to continue. See you next time. Goodbye.